Go ahead.
Okay, someone's raising their hand. Oluwafemi. Okay, you can go ahead.
Re-ask the question so the record captures it.
Okay, the question is, can someone tell me the difference between declaring a smart contract and deploying a smart contract? So, Olufemi, please, I think you raised your hand.
Jay, can you hear me?
Yeah, can I hear you?
Okay. When you declare a smart contract, you get a class hash, which you can then use to deploy the smart contracts. Deploying a smart contract is, for lack of a better word, putting it on the blockchain so that other people can interact with it.
Okay, that's good. Does anybody have like a different answer? Any other person wants to try? Okay, Eric, can go ahead. Eric, can go ahead.
Yeah, sorry, can you hear me now?
Yeah, I can hear you.
All right. So I think declaring a smart contract is what would I say? It's a way of adding it to state, so as a blockchain state, and deploying it is now like making it accessible, kind of like how you deploy websites, but then until you give it or until you let people know that okay, well, this website is available before they can now like access it and see what you have. So it's kind of like the same thing.
Okay. So I guess I'll just like remember what I said, like declaring the contract, what it does, it registers the contract on the network, registers the code and stores it on the network. While deploying, you are using that code to create like a contract with an address. So you are creating like an instance of that contract with whatever you have declared. So that's like the difference. I was kind of expecting somebody to say like use that word register, registers the contract and it gives you a class hash. Then deploying now creates an instance of the contract. So I guess that's clear. So can someone tell me what is a key store? There was a key store. I think we did it when we did Starkli. Well, what do you understand by key store? Anyone? Okay, Emmanuel, go ahead.
Okay, so I feel a key store is used when you're trying to hide your private key.
Yeah, you're right. Does any other person have? You're right. You're right. Any other person have not? Please, I think okay. Someone's mic was on. Anyone else like another like explanation for what a key store is? Okay, someone said the key store is a more secure way to save your private key in an encrypted way. Yeah, that's exactly correct. So a key store basically encrypts your private key so that like you can like basically so it can be like private. So yeah, you're right. So it means you guys are listening. That's good. So we stopped at like we're writing like an ERC20 contract. Did anybody like manage to look at it and like try their hands on it? Did anyone try and like maybe you faced like a problem or a question that you had? Anyone? Anybody? If not, then can say no so I can continue. Can you guys hear me? Okay. So let me share my screen. So no one like tried out or looked at the code I shared. Can you guys see my screen?
Yes, sir, we can, sir.
Okay, so today we are going to try and test, like deploy our contract, like test it, like all the various things we can do, like actually try and use like Starknet Foundry and like see how it works. So let's go to our contracts. So this was the contract that we used the last time. Can you see my screen? Is it moving? Is it stuck? Can you see my screen? Like, can you see what I'm doing on the screen?
Yes, sir, we can't.
You can or you can't?
We can see it, sir.
Okay. So I added something to like some things to the contract that we didn't have before, just so we don't like waste so much time and just go straight to deploying. I added a mint function for us to be able to test, like, you know, this is like a token and we cannot do anything if everybody has zero balance. So I created this function to like help us like at least give one person a balance that we cannot test transferring or something. So I created a mint function. There are some other things that were not also here. There was not a constructor. I created a constructor. Like to write a constructor in Cairo, all you have to do is write a function that like it has the name constructor. Exactly, you can't give it another name. And also you put this constructor macro attributes. I think you can actually give it another name, but it's just like a standard. So like this is what you should follow. And we set like a name for this ARC20 to whatever is passed by the person that deploys the contract, and then a symbol. And we have something called a total supply. Like every token has like a cap, like maximum amount of tokens we are going to like launch with. So I basically just put like a constant that says 100 million tokens. That's what we're starting with. Then I also added some events. Who here knows what an event is? Please, if you have like a list here, can you? Yeah, okay. Yeah. Oluwafemi.
Based on my little understanding, I think an event is like a struct in a sense that you can emit in response to certain activities, basically.
Yeah, you're not wrong. Someone said Hillary said the short dispatcher. You're not also wrong. So what's an event is? So basically, our smart contract is kind of isolated on the blockchain. External forces, like you can interact with this contract now from outside the contract, and interact with this contract from a front end, from a script, whatever. But there's not really a way for this contract to interact with the outside world. Like when something happens, like we call it an event in the real world. So when something happens, how do we tell the outside world, like the non-blockchain world, that something has happened? So that's what an event is basically. Just like allow us to be able to alert like front ends and like anybody listening to whatever happens. So that's basically what an event is. Can someone like explain what I just said in like their own words? Anyone? Precious, are you saying anything? Can anyone try at least? Just try. Please, someone should try.
So I lost you for a moment. I didn't really hear the explanation you gave.
Okay. So I said, can you guys hear me now clearly? Like everybody can hear me.
Yeah, I can hear you.
Okay. I said our smart contracts, people from outside the contract can interact with it. They can call these functions, but the contract cannot do the same thing. It cannot like communicate with the front end or like with somebody's code outside the blockchain. It can communicate with other contracts, but it cannot communicate like outside the contracts. So events allow us to do that. Basically, when anything happens in the contract, we can alert front ends or anything outside the contract that something has happened. Basically, like an event in the real world, that you have like a reminder or something. So whenever something happens, we emit an event, and then a front end can listen to it and perform an action based on that event. So does that make sense? Does that make sense?
Yeah, it makes sense. Yeah.
So can you like, can someone now like say they are like on the way they understand it, what an event is? Somebody should try. Are you guys scared of trying?
Okay. From what you said, it sounds like just like the way notifications work on our mobile phones. You send a message to someone, the person's phone, alerts them that okay, a notification has come in from so and so, and once the person sees the message, he replies. Once he replies, you get a notification as well. Basically, that's how it works.
Yeah. That's like a good way to see it actually. So that makes sense. At least someone understands. So we added like 2 events. We added a transfer event. Did someone ask a question? Yes. No. Okay. We added 2 events. We added a transfer event. So this event will be emitted anytime like funds are being transferred. Then an approval event will be emitted when like, remember I taught you guys what an approval is. Can someone like explain downwards what an approval is? This last class I will be engaging more with you guys. So remember what like an approval in an ERC20 token is, like basically what it does. If you don't want to talk, you can say it in chat. So like not be like, you can type it in chat. Anyone? Yes, so you know it's why are you so scared? It allows someone to spend tokens on your behalf. Yes, exactly. That's very correct. So to write an event in Cairo, we define them using structs like the individual events. We have a struct here that's transfer, has a from, a to, a value. We also have another struct that's bit like an owner, a spender, and a value. And then we mark the struct with like a Starknet event. This is like a trait to show that it's an event. And then these are the individual events. And then we have to group all the events in an enum. Transfer enum, approval enum, and then we put the individual ones here. They will mark it with like an event marker. I know it looks complicated, but this is like a way to define an event. Define the individual events, and then define all of them in an enum. Yeah. Does anyone have a question? Yeah, this code I shared it with you guys last week. Well, it seems like nobody like looked at it. I shared like a repo. I shared it on Telegram, and Kelvin also shared it for you guys on your WhatsApp. So you guys should have seen it. Well, I'll share it again here. Okay. Okay, so this is a repo. You can clone it and try it out. So another thing we added that we didn't add in the last class was this keyword that we added to this implementation block, this ABI. So basically, without this key, without this implementation is what we call an internal implementation. That means that this function like you can only call them inside the contract. Anybody outside the contract cannot access them. Like they can't like view them and access them and call and write and read. So in order to make like an implementation, like basically like an external implementation, you want like it to be able to be invoked from outside the contract. You have to give it this keyword ABI. Without this keyword, you cannot access these functions outside the contract. What I said just makes sense. So does anyone have a question on what I just said? Please ask me questions. Yeah, like all the functions are basically like APIs, but you know, some APIs are public, some are private. So if you don't give it this keyword, all these functions, they are private and they can only be used inside the smart contract. Once you give it now, then this keyword, you cannot actually call them from outside the contract, both inside and outside. So you are basically making it public. Just like the way you have this pub keyword and it's kind of making it public. This does the same thing, but for a smart contract. Does that make sense? Does that make sense? Yeah, I'll be asking you guys questions because I've been feeling like there are like 5 people that really pay attention and some people are just like muted, not really listening like that. So, okay, so that was basically everything we added to the contracts. I changed a little bit, but not so much. Yes, we didn't add any other thing. So let's go ahead and try and like test this smart contract. Okay, yeah, I also added something. I mentioned that I added events. We had like this transfer and approval event. So how do we call these events in the smart contracts? Like you can see when we transfer a token at the end of like the last line, you can see a self.emit. This is how you like emit an event, self.emit. Then I just put the transfer
Right.
struct. Yeah, you have
I
a
think
question?
your screen is frozen.
Oh, it's frozen. How about now?
It's fine now.
I'm using a bigger screen today, so yeah. Okay. So this is the transfer function now that transfers like from the sender to a recipient. You go to the bottom, you see a self.emit. This is how we emit events, the events that we have been talking about. To emit an event, we use self.emit, and we'll pass the events that we created. This event now is a transfer event with a from, a to, and a value. Also, if we go to the approve, we also have a self.emit. And then we just put in the approval. So this is something that we didn't do the last time, but it's also very important. Emitting event. Does that make sense?
Yes.
Yeah, so in your contracts, whenever something happens, you usually have to alert the outside world somehow. So like try and be adding events to your contracts. So let's go ahead and go to this file. So remember I told you guys like Starknet Foundry allows us to test our contracts, right? So it does that by like does that in 2 ways. Like if we go to our scarb.toml, look at scripts, we see smforge tests.
Yeah.
So smforge test allows us to like run test commands basically and test our programs. And then the other thing is, does someone have a question? Because I'm hearing someone else. Oh, someone said, Precious, I think you have to unmute, or you have to mute yourself. Someone said, does Starknet support Ethereum standard for fungible tokens, or does it have its own standard? It supports the standards. Like if you look at, although there are some like little additions, but this is the interface for an ERC20 token: get name, get symbol, get decimals, get total supply. It's basically the same thing with the ERC20 standard. So yeah, it does. Anyone else have a question? So, like I was saying, SM Forge, Starknet Foundry Forge, gives us something to test our contracts. And then if we go to our actual test file, our test folder, we have something over here called SM Forge STD. So this is like a library that SM Forge gives us to be able to do like different things in our test environment. When we test our contract, we want to first be able to like declare the contracts, deploy it, then like test different scenarios. So this SM Force standard library gives us like various functions. There are some they call cheat codes to be able to actually test our contracts. So like let's try that out. Let's delete what is here and write our own, just start from scratch. So the first thing we need to do is try and deploy our ERC20 token. So to do that, we have to like import it. So remember to import, we use name of this file is GIDA token or GIDA ERC20 rather. Then
Sorry, sir. Can you zoom in your screen a bit, sir?
okay, can you see it? Is it clear?
It's clear. Yeah. Can you full screen? Full screen too.
If I do that, can you see it? Can you see what I'm doing?
Yes, sir.
Is it frozen? You can see it. Or it's
No,
frozen.
it's frozen.
That's the issue I've been having throughout this class. My screen freezes anytime let me try on sharing or sharing. Maybe that will solve the problem. I don't know. Stop presenting. Okay. So it's on full screen. Can you see it? Like, can you see my mouse? Can you see it? Can you see it?
Yeah,
No,
you guys
Why don't you
no,
see it?
sir. There's no
frozen like that.
action.
Okay, you can't see anything again. We have to try and manage this somehow. I'll try and increase it. Is it better now? At least. Is it better? Okay. So let's try and import our ERC20. So this remember you guys were taught about like dispatchers, like what a dispatcher is, right? Am I wrong? Am I wrong? Can someone tell me what a dispatcher is? Please, someone like explain your own words what a dispatcher is. You can say it in the chat. Allows contracts to interact. Yeah. Okay. Yeah. So a dispatcher allows us to interact with other contracts, basically. So it seems like you guys know. So we have to import a dispatcher so we can interact with this ERC20 when we deploy it. So I think it's let me record it IRC20. It should be IERC20. Just give me a minute. Okay, I think I know why it's not working. We have not. GIDA ERC20, then should automatically I was hoping for an auto let's just go ahead and do it without the auto completes. Did we export this token? No, we did. Dispatcher. I hope I'm spelling it well. I think I'm not spent, but I'll figure this out. That will not be a problem. But let's just look at this function.
There needs to be a T between the A and C. No. PATCH. Yes.
To get back to this, I'll just copy the code. But okay, let's look at this function. So to test anything, we always test in a function. So let's see what we are going to test first is like we're going to deploy the contracts and like check that the name that was supplied, the name, the symbols are correct. So let's see deploy ERC20. That would be the first thing that we'll try. So it's a regular function, and we're not passing any arguments. So to mark a function as a test, we use the test attributes. Basically a macro, just like the other ones I've been saying. So you notice like we have a function here called deploy contract, and it does not have a test attribute. So it means that it's not a test function. So why do we have this contract? So for all our tests, we have to deploy, like basically deploy the contracts. Like, so if we're testing it like a transfer test now, we have to deploy the contract before we can transfer. If we're checking balances, we have to deploy like for every single test. So to simplify that, we write like a function to deploy the contracts. Someone has a question? No.
So I don't know whether I'm the only one, but there's no movement on your screen.
Oh, really? Is there any other person seeing my screen?
I can see your screen.
And you can see like me typing something.
Yes.
Yes.
Can you try rejoin me?
Okay, so this function, what it does is allows us to deploy the contract. But like I said, SM4 standard library gives us like some functionalities, like we can see it imports a declare function. So we know that when we are writing smart contracts, after writing them, in order to deploy them to the network, we have to deploy them first and declare them first, and then we deploy. So that's what this function does, but it's doing it in a test environment. Like everything in this folder is just a test. It's not live on like the actual blockchain. So it gives us a function to declare, like easily declare a contract. And when we declare, we pass a name of the contract, and then it returns like a class hash, like we have been saying, right? Someone said you did not declare an interface for the function. Is it writable that way too? I don't understand the question. Do you mean in the test folder? Person asking the question. Are you referring to the test folder? Or you're referring to the contract?
Aziz Alat, I think you can unmute so it will be faster.
Okay, seems like let me go back to what I was doing. So we have a deploy contracts function that helps us deploy our contracts. We pass in a name. We can have multiple contracts in this our source file. Now we just have an ERC20 contract, but we can have like an ERC20 can have like child contracts, or we can actually deploy multiple contracts. This can be a code base as like an NFT contract, an ERC20 contract, but we can deploy any and all of them with this deploy function by providing a name. So after deploying, like we pass that class hash. We use we use the declare function, and then it gives us a class hash. With that class hash, we now contract.deploy. This contract represents the class hash, not the actual contract. We now do .deploy, and then it deploys our contract, and then returns an address. Does anybody have any confusion with this function, this deploy contract function? Yeah, okay, Manu, you can ask a question.
Sorry, sir, can you like generally come again the whole
Okay, maybe I'll have to write it myself so I guess will. Okay. So this file allows us to test our contract. Everybody understands to that point, right? Right?
Yes, sir.
Right.
Okay. So SM4 gives us a library that we can use in our tests, allows us to declare our contract and also deploy it, and gives us things called cheat code that we can use to just basically test every single scenario in our smart contract. So it's basically just a testing library. I remember when we talked about SM4, we said SM4 allows us to test our contract, and this is one way it allows us to, giving us a library for testing. Does that make sense? Did I lose anybody there? Okay. So then I now said that to test, if you want to test a contract, you do it in a function, and that function has to be marked with a test attribute. So that's why we marked this function here. But in order to test our contract, we have to first deploy our ERC20 contract, right? So we can just deploy it, but it's kind of standard that we write the deployment logic in its own function so that we can call it anytime. You get what I'm saying? Does it make sense to that point? Okay. So like I was saying now, SM4 gives us a library to declare and deploy our contracts. So let's say deploy. We pass it an argument, the name of the contract we want to deploy. And then we return a contract address. Remember, when we deploy a contract, it gives us, like, we basically have an address that we can now use to communicate with the contract. So let's call this class hash because we need to declare the contract first. And we say we use a declare function that is provided from the SMForge standard library. Say declare. And we pass in the name we pass in a name for the contract that we want to declare. I'm sure you guys know what like an unwrap does. Then this declare returns a contract class. Contract class is the same thing as a class hash, just like we have been saying all this while. And when you declare a contract, it gives us a class hash. So to get the class hash, we do dot contract class. Then with that contract class that we just got, we now use to deploy the contract. We'll say the class hash rather dot deploy. When we deploy a contract normally, when you're deploying a contract, remember in our ERC20 token, we have a constructor. We have like some variables that we pass to the contract to initialize the contract. So when we are deploying, we also have to provide like basically a constructor. So the constructor goes inside this deploy, like as a deployment argument. So let's try and define like the constructor. The way I define my constructor, I prefer using a struct. I call it ERC20. Oh, sorry. ERC 20 arguments. And then what are we supposed to pass to the contract? We're supposed to pass a name and a symbol. So let's say okay. So let's say we're supposed to pass a name that is a byte array, if you guys remember. And then also a symbol. Symbol that is a byte array also. Symbol is a byte array, yeah. So we have to pass this argument now. Like this argument represents the constructor. Is anyone confused with that? Yes, I have to explain it. Does that make sense to everybody? Okay. So we're basically just simulating what we will do, like what we have been doing with like Starkli and SMForge, that we deploy the contracts and we declare the contract and deploy it. But we're doing it in a test environment basically. And we can't achieve all this without this SMForge standard library. Get what I'm saying? So everything we're doing in command line, we are doing it in a test environment with code. Get what I'm saying? Okay. So to deploy the contract, we pass the constructor as like an array, because we have a name, a symbol, so it's kind of like an array. So what we're going to do is let's create an array to contain the constructor. I'll say create an array. An empty array. And then we're going to fill this empty array with these arguments that we're providing here. Okay. So let us see. Let's define the arguments and say it creates an ERC20 argument. Give it a name. My editor is not giving me autocomplete. I think I need to put it and go into it again. Now we can get autocomplete. Okay. We'll give it a name. So we're going to call our contract like GIDA token, or just call it GIDA token. And then the symbol. Is there anyone that is not following what I'm doing? Symbol, call it GIDA. So I've created like our constructor. So we have to pass it now to the deploy function. So we have to somehow, yeah, we have a question. I thought someone was saying something. We thought the constructor had 3 arguments. So we kind of, in our constructor, we gave like a default total supply. So we are not telling anybody to like provide us with a total supply. We created like a constant that contained it contained 100 million tokens, and we just passed it in the constructor. So we are only asking for 2 arguments, the name and the symbol.
Oh,
Yeah, just 2 arguments. So like the normal standard way of doing this, normally we have to somehow like pass these 2 arguments, name and symbol, into like this array constructor. But the problem is we have to convert all of them to a felt, like because like the arguments that we're passing to deploy function is an array of felts, so we cannot pass in like any other kind of type. So that's why I'm kind of going through this extra step. I created an argument. I have to add something called STRK, and then I'll serialize everything to a felt, so we can pass it in the deploy function. So adds dot serialize into the constructor arguments. Then we pass that constructor argument here. I'm getting some errors. Let me see my entire screen. Okay. We have to import this Starknet contract. It was imported already. Okay, I understand why it's giving us an error. So this thing returns, when we deploy a contract, it returns basically the address of the contract. You know, say address is equals to this. And then we return it. So before I go ahead, does anyone have a question? Let me answer some questions. Does anyone have a question? Okay, the derive it's not drag, it's drop and steady. They are both like, they are macros basically. This is like derived macro. They are both attributes. So this drop attribute is kind of compulsory for every structure we create. I can remember you guys were talking about ownership in Cairo. So anytime like we use a variable, it has to be like cleaned from memory basically. So this drop actually does that. When you are done using a variable, it just drops the variable. Then this third is what allows us to call this serialize function. It allows us to serialize like from any type to a felt basically, but it's mostly for structs. These are our custom type I've created, and I'll turn everything here into a felt. And that's like a requirement for this deploy function. So that's what it was. Was that confusing in any way? So SED stands for serialization and deserialization. Yeah, if you have seen it in Rust before. So I'm getting an error. Say expected Starknet contract address, found Starknet contract address, found. Okay, I get what's. So this actually returns a tuple. That's why we're getting an error. And the first thing it returns in tuple is the address. You can ignore the other one. You can see that the error has gone. So what we just did now is try and deploy our contract in a test environment. We declared it and it gave us a class hash back. And with that class hash, we now deploy the contract over here. But we had to pass in the constructor arguments, which was why we did this whole ceremony, like creating like a struct to contain the arguments and then passing it into the argument and into the deploy. Yeah. Does that make sense? Yeah, it's kind of like, it's not really like typecasting per se. Like I said, if you're a JavaScript developer, there's something like you see like it's JSON does serialize. CLE kind of allows you to convert from like your regular data types to different formats. Like you can convert to like a JSON, a CSV, wherever. Well, in this case, CLE is converting your custom data type, which is struct, to basically like an array of felts. Yeah, that's what it does in Cairo. But in other programming languages, serialization means converting from your regular data type to like JSON or CSV or another format. So the way we could have passed this argument is like doing it one by one. We'll have the name, we'll convert it to a felt. So we'll have the symbol converted to a felt, but I prefer this way. Just give everything in a struct and just serialize it. So does that make sense? Does that make sense? Okay. So every function we write, we are basically going to always do this. We are going to write every test we write. We have to first deploy the contract. Not every contract has constructor arguments. So if it does not have, we pass an empty array, and we don't have to go through this whole process. But the contract we're deploying has a constructor. So we're going to write a test here. The first thing we're going to call is this function, this deploy function. Deploy contracts. You can see why it's useful now. And then we'll pass in the name. The way we pass in names, let's go to our file. What do we call our contract? We called it an ERC20. It's over here, yeah. Called it ERC20. So we're going to put this name. I think I want to just make this all capital. So come here, that name now we'll get to our contract. That's what we'll pass here as the name. You can see how easy it just makes our life. Like we don't have to import so much to deploy the contract. We just give it a name, simple name. It looks like magic. Like how can you just give it a string and it just knows the contract to deploy? So if you had like multiple contracts here, like you have like another contract in this file, we also just give it a name and to be able to identify the contract you are referring to. So this deploy contract, like we saw, it returns an address. An address can allow us to interact with the smart contract, but it's not enough. That's where we need dispatchers. I can remember you guys did dispatchers, like the last person that taught you, and use it to communicate with like another token, like an ERC20 token. So we're going to import a dispatcher here in order to interact with the contract. So that's exactly what I was trying to do here. Import a dispatcher. My keyboard is misbehaving. So if we go back to our contracts, we labeled our trait with an interface. So basically what this trait does, this attribute does, is it generates our dispatchers that we now use to communicate with contracts. So this was in charge of generating the dispatcher out of this trait that we gave it. I'm not getting autocomplete today. I don't know why. Okay, I think I'm going to get it now. And I ERC20. Let me just go to the example that we had. Copy it from there. I'm looking for a dispatcher. I'm having problems spelling it. Let me try something common. Oh, okay. I understand why this has not been working. So this dispatcher exists in the ERC20 file. So we actually have to pass like the ERC20 module, ERC20, and then we cannot find the dispatcher here. That's why we have not, like you can see now, we have a dispatcher, and then we import dispatcher trait also. Yeah, this. Does anyone have a question? Any questions? Does anyone have a question? Should I go ahead? Because I need some feedback from you guys. Okay. So now to interact with the contract, just like you guys did in your previous class, we now use a dispatcher. So let's see, let's ERC20 is equals to, we'll call that dispatcher IARC20 dispatcher, and then we'll pass in a contract address. Does what I just did confuse anybody? Please, you guys should ask me. If you are confused, please tell me. Any questions? Or what do you want me to explain? The dispatcher. Okay. I'm sure you guys have seen this before. I kind of watched your classes. I saw this dispatcher now. It's a type that's generated by the compiler. It's generated from this Starknet interface, these traits that we give that we have a get name, get symbol, get decimal. So it allows us to interact with this contract now, basically. And like you can use it inside the contract to interact with another contract. So that's basically what a dispatcher is. It allows us to interact with the contract. Those is a type that allows us to now like interact with the contract. And the argument we pass is a contract address. So the way we will normally do this is we'll give contract address, like we pass it as an argument, but in Cairo, if the argument and the name of the variable you're passing is the same, you can just omit it and just pass in the contract address like at once. Does it make sense a little bit now? Okay. So I guess that must have been a little bit confusing. So we have created an ERC20 token now, and we can now interact with it in our test environment. So if you say ERC20 dot, we now start getting all the functions in our contract that we can call the get decimal, the get name, the get symbol, and whatever. So let's try to get the symbols. Remember over here in our constructor, we gave it a name and a symbol. So let's see if that's what it will return. But before that, I think we need to define our name and our symbol in the constant, so we can reference it anywhere. So let's see token name. GIDA token. Then also the token symbol. Sorry, my system today is misbehaving a little bit. Then passing the symbol, I will give it GIDA. It's not supported as a constant. There's really no reason why this should be giving us an error. Let's just make it a regular variable. what I'm trying to do is make this name and our token global so that we don't have to write the string all over every time. For some reason, it's not working, so I'll just skip that. So let's try to see the name of our contracts. I think it's get name to get the name that we passed in. And in order to test, we use the assert keyword. Who remembers the assert keyword? The assert macro rather that we use inside our contract. Yeah. So in order to test like that something is correct, we also use it here also. So to see if the name, we use an assert, the assert macro. I will now check this erc.getName. I want to check if it equals to this name, GIDA token. And if it's not, throw an error, like invalid name or something. So this assert keyword, it helps us in our contract and also for our tests. In our contract, we use the assert keyword to basically panic whenever panic whenever something that we don't want happens. For example, when we transferred and we want to check if the person had enough balance, we use an assert to check and say, okay, if you don't have the recovered amount, then this program should crash. But in a test environment, the assert allows us to check like basically the validity of some things. So we are checking that the name that is passed as a constructor, when we type the get name, is exactly the same name that is returning. So we're basically testing that function. So let's try testing this. Go to our terminal. Yeah. Can you guys see my terminal? My vscode terminal. Can you see it? I can't really see. Okay. So to test, we do Scarb. Let's first go to our Scarb.toml. If we go under the script, you see test is smforge test. So let's say Scarb tests. It will now run the smforge test rather. Just give it a little while. Yeah, so we can see our test passed. So you can see it has one test running and the test was completed. One test passed, 0 failed. So we can have multiple tests. Like now, what we just did now, we tested this deploy ERC20 to see that it actually deployed and like it has the same name. We can have another function now that tests something totally different. So let's try that. Let's say we are testing. Okay, let's mint the token basically. Let's like transfer token to somebody that does not have. So let's say test mint. Remember, we created a mint function to help us with that. So like I said, every function in the test must be tagged with this test attribute. If it's not tagged with test attributes, it will not recognize as a test. So we also have to add this. And then we have to redo this all over again. Deploy the contracts and initiate it. So to test the mint function, let's call ERC20 token dot mint. So the meet function takes 2 arguments. You can see it here. Yeah, it takes an account, the account we want to fund, and then an amount. So let's do that. We have to give it an account. So there's a way to generate accounts. Like when you are testing, you are going to need to like create basically fake addresses, rather fake addresses. So to do that, Starknet gives us a particular function that we can import inside the Starknet module. It's called const. Please give me a minute. My autocomplete has gone away. Yeah. So if we look at this, we see a function const. Okay, yeah, contract address const. So this allows us to just basically create addresses in our test environment that we can use to test. So let's try it out. Just create like a fake account that I want to supposed to contract address const. I know it looks very weird, just bear with me. And then we can pass in a name. Let's say I'll use my name SAS. Oh, sorry, I'm supposed to pass it over here. Yeah. So this kind of creates like, it's not a real account, but an account that we can use for testing basically. Does anyone have a question? How do you pass byte array value to Voyager or? So there's like a library, there's library Starknet.js. When you're interacting with the blockchain, you are going to use it. When you're interacting with the blockchain, basically, all your types are going to be converted to a felt. So you don't really have to worry. I can remember when we deployed our contract, we had to convert everything to a felt in order to now like send it as an argument. So every single argument, no matter the type, it will be passed as a felt get. So that's why that serialize and deserialize is important. I will try it out. I think you guys are going to do that when you are doing front end. Yeah. But like as you can see here, when we deployed our contract, everything was converted to a felt, like as you can see. So that's basically how it works. That's why we need this STRK to be able to convert all our data types into a felt. So the interaction between the smart contract and off-chain is done with felts. So we've created an account. Let's pass it here. Pass an account, and then how much we want to mint. So let's say we are minting 200 GIDA tokens or 2000 GIDA tokens. So let us test that this mint function actually works. So we say, let's store this in a variable. Let's say ERC20 dot balance of. Let's check the balance of the contract. Balance of this account we just created, and we're checking that the balance is equals to 2000. Yeah. And if that does not work, we throw an error. Incorrect balance. So let us try to see, like, let's test and see, like, if we pass in the wrong, like, value, if this test is going to fail. So we are minting 2000 token, but let's say we want to, like, let's check that it's equals to 3,000. So this is wrong and it's supposed to fail, but let's see if it's actually going to fail. Say Scarb tests. Yeah, so we can see that we have a failure. Our test did not pass. We had two tests. We had a deploy ERC20 test and also a test means to test to try and mint our token to an address. One of the tests passed, one of them failed, like we can see here. Tells us one passed, one failed. So we can see that, like, if somebody passed the wrong input, it's actually going to fail. So now let us change this back to 2,000. The balance that we mint here is 2,000 and try it again. Yeah, so we can now see that the test passed. So normal conditions, we are supposed to test. Like testing is very, very important. Like it's like you cannot write a contract and just deploy it on the network like that. So you have to test every single thing that you write. You have to test it because like there are people that are always looking for loopholes in your contract, ways to hack you or wherever. So you always have to test every scenario in every system that you create. You must test it. I think you guys are going to do like a class that is on testing and they are going to expatiate on why testing is important, but I just wanted to drop that. So normally we're supposed to test every single thing to make sure that when we call this function, it goes exactly the way we planned and we are not having any unforeseen, like anything we did not plan basically. So we will not be able to test every single thing, but we can see how SN Forge standard library has allowed us to be able to test different things. Does anyone have a question? Does anyone have a question? Okay, Eric, yeah. Please go ahead.
Yeah. So the byte array stuff you did in test, yeah, that's for the constant set token name and also when you pass the arguments to the ERC20. I saw that your own didn't give you any errors. Well, on my own end, I'm getting errors about mismatch types. I'm not exactly sure why.
Where? What line?
That was on line 12, I think. You scroll up. I think it should be line 12. Okay. No, not line 12. Okay. Yours is line 12. It's okay, it's no longer there again. Okay, but the errors I'm getting now, that let argument line 24 now, I'm getting an error there regarding the name, saying that mismatch types. I mean, I'm looking at yes, yeah, that line. That's GIDA token, yes, that's why I'm getting an error.
Are you sure you're not passing like single quotes? A byte array.
Okay.
Single quote represents a felt, yeah. So it's in double quotes.
Okay. All right. Okay, yeah. Wow.
So there are other things we can do with Starknet Foundry in our test folder. I have something here. Yeah. So there's something called force testing. You guys will be introduced to it, but like later when you do test. But these are some kind of things that we can do. Like we can fork the network now. Like for example, like now we are when we are testing in a test environment. But if we want to test in the actual blockchain, we can pass some arguments to our test. So let's try it out. So we want to test this means, and we can just pass an argument basically, and say And then remember we had like an RPC or something. So let me pass my RPC. So my RPC. So let's try Scarb test now. And what is going to happen is that this particular function, the test mate function, is going to test it. This one is going to be tested. The first function, I think we have two test functions. We have deploy ERC20. It's going to test this one in a test environment, but this one is basically going to fork this Sepolia blockchain and test it in that environment. You get what I'm saying? So these two functions are not going to be tested in the same environment. So this is like a very easy way that we can just like recreate the Starknet blockchain, like fork any like a testnet and just test our functions and see how these functions will behave in an actual environment, like even in mainnet itself. Does that make sense? Does that make sense? You can see how easy it is that like without SM4 you cannot do most of these things. So with SM4 you can do other things. There's something called force testing. You guys will look at it later. But basically, in our contracts, we are the ones passing the arguments, but we can let the compiler give us the arguments. Like this account now that we give and this amount, we can actually just do like address here. And amount. So once you pass an argument to a test function, this argument, the data will automatically be injected by like SM Foundry, like Starknet Foundry rather. So over here, we don't have to define it like an account or an amount. You can just pass it straight from, just pass an amount and an account, and it's automatically injected. Let's try that. Okay, we have an error. Okay, I get what is happening. So remember in our contract, the amount was actually U256. So that's what we are supposed to pass here. So let's try that. Just see what's giving us an error. I don't want us to get stuck on this, but basically what fork testing does is like we don't have to pass our own arguments because we can't predict every single scenario. So we let the compiler do that for us. The compiler will give us an address and an amount. Yeah. So that's what force testing does. Another thing we can do is something called cheat codes. I don't think we're able to look at them today. So what does this cheat code allow us to do? So for example, we want to like deceive the contract, for example. Like we want to like okay, remember in our contracts we had like we had some asserts that said like okay, it was in our get color or something. we want, okay, yeah, it's over here. So the person that calls this contract now is who we are going to deduct from. So we want to try that, for example, now that someone else cannot like basically withdraw on your behalf, somebody that you did not give permission to. So a prank can allow you to basically just like deceive the contract and say, okay, this is somebody else, and then you can now test like different scenarios. I want us to just go straight to like deploying this contract because we have kind of taken so much time on this. But is there any question? Is there any question? Any questions before we go to deploying? Or we kind of have limited time. Okay, the test code. So we just wrote two tests. We wrote the test to deploy the contract and we checked the name. And it was equal to the same name that we passed. And then we wrote the test to mint tokens. And then we checked that the amount that was minted was correct by checking the balance of the person we minted to. So the next thing we are going to do now, remember we said Starknet Foundry comes with two packages. We have SM Forge and we have SNCast. So we want to try and use SNCast now to deploy our contract. Like we said, SNCast is basically like Starkli, allows us to declare our contracts, deploy them, and also interact with them. So we're going to try and do that. So before we do that, let's check if we have SNCast installed. Yeah. Remember, I told you guys before you do anything, use the help command to see what you can do with the package. So we can declare a contract, we can deploy it, we can call, we can invoke, and create an account. Yeah, and we can verify a contract. So what we want to do now, we want to deploy this contract in a test net. So you guys still remember Starknet Foundry and Katana? Are you guys there? Hope I've not lost you guys. If you are lost, you can say so. Okay. You're lost? Okay. So let us now terminal, let's do Starknet DevNet. Yeah. So it has created a test net for us, developer network with addresses, with accounts pre-funded already, with their private keys and their public keys. So we want to try and deploy this AS20 now on this test net. So we have to kind of keep this running and open another terminal to basically deploy. So the beautiful thing about Katana is that it comes with accounts. Remember before when before we were able to deploy or do anything, we had to create accounts. So Katana and Starknet, they come with accounts already with private keys, so we don't have to go through that all over again. So we are just going to use the accounts they are provided for us rather than creating. So to use an account, do SNCast account, and we'll try the help. So we see there's a command here, creates an account, just like we did with Starkli in the past. Deploy deploys an account just like we did with Starkli in the past. Delete can delete an account from basically from your system. All we're going to use is this add. So what this add does is we already have accounts already in the blockchain. So it's basically going to fetch them and put the keys and everything in our local environment on our system, so we can sign transactions basically. So we're going to do SNcasts accounts ads. So if we do the help command, let's see, it's telling us to pass some things, like we have to pass an address, we have to pass a name, we have to pass private key, and the URL also. So let's try that. So luckily for us, Starknet DevNet has already given us an address already, so we're just going to copy it. Also asks us for a private key. Let's say private key. I'll pass the private key provided here. Let me check if there are any questions. You are not recording to the question. You are not. Oh, sorry, I was not responding to the questions. What's your question? John Williams. What is your question? You guys can hear me clearly, right? There's nobody saying anything. Okay, the byte array, like I said, you're not passing byte array. And like any function you're passing under the hood, converted to a felt. Like you don't have to worry about that. There are libraries that help you do that already. So it's not something you pass your normal JavaScript data types and to convert it to felt and pass it to Voyager. So you don't have to worry about that. Is that okay? You are trying to interact with Voyager. And what is it telling you? Okay. I think maybe after the class, if you can, I can actually share my contacts. If you're having a problem with that, I can help you. But this kind of not in like the scope of what we are trying to do right now. So just like hit me up after the class and I will try and help you out. Okay, so we are trying to add the accounts that already exists in our Starknet DevNet. So we passed in the address, we passed in the private key, and was passing the URL. So what URL are we going to pass? So Starknet DevNet gives us like an RPC endpoint, just like we have been copying. Gives us a localhost RPC endpoint that we can use. So let's copy that. No, I think I didn't copy it clearly. Let me just write it out myself. Does someone have a question?
Not a question, but I just wanted to say that you kind of killed the Starknet DevNet process that was running on the other terminal.
Oh, okay. Okay, so we have it back. Do I have to change anything? The account, I think the accounts change. I have to change this address again. So let's copy this address. And copy the private key. So normally, if we were deploying to like a testnet now, we have to actually create these accounts on like our private key, our key store, wherever. But since we are just testing, let's copy this. We don't have to go through the process of creating an account because it's already created for us. So let me copy this. Yeah. So let's try this out and see if it will work. So you can see it's asking us for two extra arguments, a name for our account and a type. So remember when we were creating accounts, we said like all accounts are smart contracts and there were different types. We had an open Zeppelin account, we had an agent account and the browser's account. So this type that is asking us, that's basically what is asking us, like the type of contracts. So I believe every single contract that is deployed here is an open Zeppelin contract. So we're going to pass type OZ. And then it's asking for a name. Name is just, we're just giving our account a name so I can reference it later on. Let's see name and call it GIDA accounts. And then I want to pass one more argument. You guys are going to see like how it works. Let's see, it's called an art profile. The profile is going to help us a lot. Just when I press enter, I'm going to see what it does. And let's give it a profile name, dev profile. And press enter. Let's try it again. I think there's something wrong with our RPC. Oh, I gave it an HTTPS instead of an HTTP. Yes. So the extra command we added, the art profile, created something for us. Let's go to our file and we'll see a new file was created, smfoundry.toml. We'll go into it. You can see it created a profile for us. So we don't have to be repeating this command all over and over and over. So this file contains like our information for like our deployment information, the accounts we are going to use to deploy, like the paths to the account. And this is also actually supposed to contain the URL that we give it. So let's just copy the URL from here. This will help us so that anytime we are trying to deploy or declare, we don't always have to pass in the accounts and like private key, all this information that we just passed. And also the URL also. We don't have to pass in this information all the time. So once we just do sncast deploy to come here and just like look at our information and use it. So does anyone have a question before we try to deploy these contracts? I know the commands were kind of a lot. Any questions? Okay. Can someone tell me what SNCast helps us do? Anybody? Anybody?
Sorry, what was the question?
Like, what does SNCast do for us? SNCast. Because everything I just did was with SNCast.
Oh, okay. I would say allows us to deploy our smart contracts, declare and deploy smart contracts, basically.
Yes, and like somebody also said here, create accounts. But in this scenario, our Starknet DevNet has already created accounts for us. As you can see, it has created accounts for us. So we don't need to go through that process of creating accounts. So what we wanted to do was now add an account. Basically, fetch this account that has been created for us. So that's why what we did was we used SNCast account add. We added the accounts. We passed the address. Let me close this. We pass an address that we copied from SN Foundry. We pass the private key. We pass in a URL, basically an RPC URL, but this time it's like a local URL. Pass a type of account, which is OpenZeppelin. We passed a name. We just named our account. Then we pass something called an art profile. What this art profile did was create a profile for us, create a file SN Foundry, and then we have a profile SN Foundry dev profile that kind of contains information, our deployment information, the name of our accounts, the path to where our account was stored, and also the URL. Does that make sense? Anyone have any question? Person that asked this question, is it clear now? Okay. Okay. So let's try and deploy our contract. So to deploy our contracts, I think we actually need to declare it first, actually. So let's say
Sorry, excuse me. Before the deployment of the contract, I have a question. I just saw something. Do we always have to specify the type? I'm guessing that type should be type of the contract address. I think you put OZ, which is for OpenZeppelin. Otherwise,
Yeah.
made as a must.
They made it a must. Like when I didn't add it, the compiler basically complained that we should give it a type. Like remember when we created the type is very important because there are different, to create an account, you need like basically like the class hash of the account or something. So
Yeah.
to know which contract they are adding, you understand?
Oh, okay.
Or they
Okay,
can like
okay.
fetch the class hash or something. So yeah, it's important.
All right, no problem. Thank you.
So let's try and declare our contract. Before we do that, let's do SNCast declare help. And let's see what it gives us. So what is important to us is this flag contract name. We're going to pass the name of the contract. So normally we're supposed to pass the URL, supposed to pass an account, but because we have already defined it in this profile, we don't need to. All we just need to do is just give it a contract name. So let's try that. SNCast declare. Then we'll see contract name. And then what was the name of our contract? ERC20, right? Let's see ERC20 and try. RCO does not pass, not found in SN. Let's try again. Supposed to detect this our URL. Well, let's just copy it. Let's do that manually. And say URL. Copy it. Okay, it's asking us for something. So if you look at this, our DevNet now, it deployed 2 tokens for us, 2 fee tokens, Ethereum and Starknet. So basically what this thing is telling us that we should tell it what are we going to use to pay for gas fees. So we also have to pass that also. And see fee, I think it's fee token. And then we see, let's say we pay with Stark. And let's try and deploy. Can't name not passed. For some reason, this is not detecting our. Oh, okay. I get. I know what I'm doing wrong now. I'm sorry. So the reason why this is not like you can't find our smfoundry.toml is because we are supposed to tell it the profile that we are using. So over here, we're supposed to say profile because we created a profile, and the name of the profile was dev profile. So we'll say dev profile, and it should work. I think I have to add the profile to the beginning of the arguments before I put declare. Profile, dev, profile. Yeah. So I think just give me a minute. Well, does anyone have a question? Oh, I have to figure out why it's not working. Does anyone have a question? Does anyone have a question? If you have a question, just go ahead and unmute your mic and oh, okay. Nobody has a question. So let's try this again. The name of our contract is ERC20. So this is what we're supposed to pass. ERC20. And let's try that again. So it's telling us invalid signature. Let's try and figure out why that's giving us an issue. Maybe we didn't import the file correctly. Any questions? Everybody's quiet. No questions. Is anybody here? How does it feel like I'm talking to myself? Thumbs up. Okay. So are you saying that you can declare a contract basically? Everybody here. Let's try and import our account again. So remember the way we did it. We did SNcasts, accounts, ads, and then we passed in a name of an account. Let's give it on that account now. GIDA account 2. Give it a private key. Let's copy the first private key from here. Then we'll give it an address. Then what else I was supposed to give it? Type of accounts. I'll say OZ. Then I don't think we're giving it any other thing. And let's also add profile. I'll call it dev profile. Yeah, we're supposed to give a URL also. URL. I will copy this from here. Yeah, so I've recreated our profile. For some reason, it's still not giving us our URL. We'll just copy it here again. So let's try and redeploy again. Yeah, give it a profile, dev profile. We declare ERC20 and we'll give it a fee token. Demos are always scary. Yes, so this time it works. You can see we declare the contract and it gave us a class hash, a transaction hash. Go to the Starknet Foundry, we can see like we're seeing like some transfers are being sent to this our local blockchain. We have successfully declared a contract. Does anyone have a question? It's my declaration process. Anyone? Okay, can someone tell me why declaration process is important? Anyone? Please. I just want to hear someone's voice. Or do I need to call on someone because nobody's answering, nobody's saying anything? Okay, let me call somebody. So, Hillary, are you there? Hillary? Okay, Emmanuel, are you there? Oh, wow. Prosper, are you there? So basically, no one's.
We are here. We're here.
Okay, I want someone to ask a question. Like his composer, someone should ask me a question on this my declaration. Like I basically just declare the contract like we have been doing, but I use SNcasts. So all I did, I created a profile to help us deploy. It contains all our deployment information. And then all I did was SNcast, declare, I gave it a contract name. So is there any part of that was confusing?
No, no part is confusing. You know, we have learned a lot, and a lot. We need time to like digest and repractice so that it sticks.
Okay, but you know what a declaration is, right? When I'm declaring something. Yeah, so basically what I'm trying to do now is do it SNcast. That's all I'm doing. Exactly what we did with Starkli. That's what we are doing. I just said SNcast, declare. I give it a contract name. Now that was basically all I did. So I guess maybe the part that's confusing. So just think of this dev profile. It's just something that exists about. It just keeps track of our deployment information, like our account, our URL, all this kind of thing that we need to do. So we don't have to provide it every single time. You know what I'm saying? And when I created the account, I also created a dev profile. Okay, I guess when I'm done, I'll give you guys some resources so that it will make more sense. Because I guess this is not as simple as Starkli. So we have deployed our contracts. Let's try and we have declared it right. Let's try and deploy the contract, and then we'll try and interact with it. So dev profile, and then we'll see deploy. Let's just give it a help and see what it gives us. So to deploy the contract, we see we have the first argument is the class hash. So we always have to provide that class hash. That's why we just went through the whole declaration phase. And then we have constructor. You know, our contract had some constructors, a name and a symbol. So we have to pass that. Basically, those are the two things that we need to deploy. So deploy, and then I pass class hash. I didn't really save the class hash just now. Class hash of the contract we just deployed. Let me try declaring it again to give us the class hash. Yeah, so it says this account has already been declared. So we can see that once we declare a contract, we cannot redeclare it. So it's going to like crash and give us an error. So I've copied the class hash. Let me copy it over here. Yeah. So I'm going to use it here. Class hash. And then we also have to provide constructor. I think it's called constructor argument, AGS also. Let's just try help and see. Constructor arguments. And then the two arguments we had was a name for our token. So let's say GIDA token. So just say GIDA, then we pass in, we give a space to pass in this argument, which is like, okay, let's put it in a string. GIDA token. And then The symbol is GIDA. So we are not spelling. Oh, I call this a clash as. Clash as. Let's correct that. Okay, constructor call data rather than constructor arguments. That was a mistake on my part. Constructor call data. Invalid characters. Let's try again. Without the strings. Let's call it GIDA token without any space. And try again. Can someone tell me where like they got lost? Because I feel like a lot of people are lost. Any part that is confusing them, basically. Can someone just be bold enough to like say something, say what's on their minds? Anyone? Nobody. Okay. So I think the arguments we are passing is not going through for some reason. The class hash is correct. Now is the call data. Let's go to the documentation.
Sorry, did you also pass the contract name?
The contract name.
Yeah, did you pass it in the sort of with parameters?
No, I did not.
I don't know. I
Maybe
think
that's
maybe that's why it's not working because I'm looking at the Abi? Oh wait, let me. Yeah, I might be wrong though.
let's try that. CRC20. No, we don't really need the contract name because we have the class
Yeah,
hash. We have the class hash already.
the
So
class
that
hash
one,
is the main.
class hash
I think the class hash should be the last thing. Like all the other parameters you're adding now should like come before the class hash. Like the constructor call data should come before the class hash.
I think we're probably passing the arguments wrong because that's the error we're getting. The examples they give us here, they don't have like I can see basically the same thing that we are doing, but they are not. Okay.
Yeah.
This is the constructor.
Okay.
Maybe the command line cannot pass our strings. Basically, that's probably what's going on.
I don't think so. That doesn't sound right. Isn't that should be 0 instead of O, right? Shouldn't that be 0? Yeah. Because from what I'm seeing, the only things that are needed, either you pass class hash, constructor call data,
Well, you can see the error we're getting is invalid value.
Yeah, invalid value
Invalid,
for
invalid
constructor for
character.
Contr.
Yeah, so the error
Yes,
we're having
for the
is we're finding how to pass our constructor. It's not cannot recognize strings.
that's a bit odd.
Yeah.
Try and do this.
Invalid characters. We're doing this in the like with a script now. We will not have a problem, but our command line is not accepting our constructors. But does it make sense to this point? You guys can get what I'm trying to do, right? Does it make sense to this point?
Pretty much, yeah.
Let me try and answer questions. So does anyone have a question? We are unable to deploy our contracts because it's not accepting our arguments. But if it was, this would just basically deploy, and we can see all we just needed was the class hash, just like exactly what we did in Starkli. But like, okay, I guess maybe people may feel like this SNCast feels too complicated. But the good thing is that it's integrated in our development environment. You get what I'm saying? That initial command that we used to add our account, we only have to do it once. And creating a profile. Once you create it, like we can have multiple profiles for now. Like for example, now, like now this profile was using for a dev environment. You can create a profile now for like when we want to actually deploy to mainnet. So profile kind of allows us to separate, just like a profile on social media, separate like our deployment information, just keeps our deployment information. You get what I'm saying? And makes everything easy. So that when we declare, we don't have to be providing all this all over again. We set it up initially. We just click declare and deploy, and it works. Does that make sense? If there's anything you are confused about SNCast, please tell me now, because it's almost time for us to finish. Do you think you can attempt all I've done today? I guess I'm sure you guys understand the test part, right? Is there anything confusing there? Today's class was a little technical, but just give it a little time, you understand it. It's not really that complicated. It's probably because you're seeing it for the first time, just like me actually. When I saw it for the first time, it looked a little bulky, like, oh, what is all this, like, to keep track of everything. But it's actually not that hard. So does anyone have a question? Because it's almost 10:40. Any questions? So normally this our SNCast, the arguments are supposed to work. I've only tested this with like an argument for like they were numbers. I think if I want this to work, I have to convert this string to a felt or something for it to work. I don't know if there's any tool that can help us with that. I think this was the problem this person was having also. That person that was trying to interact with Voyager, that he couldn't pass a byte array. Let's see if we can find something that will help us. But basically, what this is doing, like we have said, is deploying the contract that we just declared, asks for a class hash, and then our constructor arguments. So this is where we're having a problem. It cannot pass our strings, our providing. I'll give you guys feedback on this. So the last thing we're going to do, because it's already time, is just like an assignment. I want you guys to practice everything you have done today with this assignment. And maybe while you practice it, to start to make a little more sense. And then you can always, like, if you ask Kelvin for my contacts or wherever, you can always get to me, and then I can explain anything that you're confused about. So the assignment we are giving you guys today, we are going to create, like I wanted an assignment that will kind of use the knowledge that we had creating an ERC20 token, creates a auction contract. So an auction contract basically just allows, like, you create an item for bid and people can like auction on it, and the highest bidder basically wins. So I'm not letting you guys figure this out yourself. I created a repo, yeah, auction Starknet, and these are the interfaces you have to follow. The contract has to register item, unregister an item, bid, and get highest bidder, and check if something is registered. This is just what you're going to implement. And then I also like give like a bare bones for the contract, like the states that the contract is supposed to have. So have like a bid, keep track of the bids and keep track of who is registered. So the assignment is to, like, I'll share this link with you guys to this repo, try and implement these contracts, add events, then try and test it using SMForge in this, like the test environment that we use, try and test the contracts, and then try and deploy it. So does that make sense? Is that okay? So let me share the GitHub for you guys. So that's our assignment. You guys should try and do it. If you have any questions, reach out to me. Just give yourself some time to process everything that I've done today. So that's all. Thank you guys for the session. So good night.